intro to the BIRC Speaker Series, which I should do every time, but I'm sorry? Yes, and friend Owl. I am Famika Haight, professor of the University of Connecticut and director of the Brain Imaging Research Center. We have been holding the BIRC Speaker Series monthly since the fall of 2018. We invite prominent speakers from around the country, as we have today, to give us a lecture on their latest research, most often related to neuroimaging. Since last September, we have made it available to those who are remote, and it's been very successful with over 25 institutions joining us remotely. So thank you to those locally and also at UConn, and also those who are remote, for making this a successful event. Please feel free to share with your colleagues, departments, friends, and families, and pets, and whoever wants to join us. We had high school students wanting to join and join some of our talks as well. So housekeeping, especially for those who are remote, please do mute yourself and send us a message through the chat box if you have problems or questions, and we'll relay that question when it's a good breaking point. So today we have the greatest pleasure of having Dr. Kata, I didn't check with you how to pronounce it, Katarzyna. I have really bad phonological memory, so I apologize, I can't repeat it, or Kasia in short, which I love, with us today. She's Emily Fraser Beede Professor at Yale University School of Medicine in Child Psychiatry, Pediatrics, and Statistics and Data Science. She's also Director of the Social and Affective Neuroscience of Autism Program and the Yale Autism Center of Excellence Program at the Child Studies Center. Expertise spans widely from clinical psychology to developmental neuroscience, data science, methods development, and more recently in brain imaging. Her research focuses on identifying early markers of core and comorbid symptoms in children with Autism Spectrum Disorder, ASD, and related conditions. She has served as the chair of the Baby Sibling Research Consortium and a board member of the International Society for Autism Research. She is principal investigator on many federal and privately funded grants, and most recently on an NIH P50. It's a big program project grant where she leads 5 major projects and 2 cores. The project takes cellular and molecular and functional imaging approaches to understanding early neurodevelopment in autism. And it's a really, really exciting project. I was getting a sneak peek of the project. And as you can see, she wears many, many hats. And if this is not enough, she has a clinical practice and she's a clinical psychologist by training, and is also committed to training the next generation of clinicians and researchers. And I was just getting a mentoring session myself earlier today, so lucky me. She has an NIH major grant due tomorrow. So we are particularly appreciative for her visit today. Please join me in welcoming Kasia.
Thank you so much, Famika, and thank you for inviting me here. It's always a pleasure to come back to UConn. The campus keeps changing, growing. It's such a beautiful, beautiful place. So it's always a pleasure to meet our folks from this part of the state and hear what you guys are doing. Exciting stuff and really exciting opportunities for collaboration. So I know that on the schedule we have, 90 minutes, right? And at the end, there's a Q&A question. So I would like to flip it a little bit and ask you to actually ask questions as we go along, because that's where your questions are fresh, and I'll be happy to elaborate if I can. If not, I'll stay 5 minutes. So I would like to talk today about 2 lines of research in my lab. One is a newer line of research focused on affective, emotional development of children with autism, and the second one is one that I've been pursuing for the past 20 years at the Child Studies Center that's focused on social development of kids with autism, with particular focus on selective social attention or attention in general. Before I start, I would like to introduce to you our team. More people than in this particular picture, and our group is very interdisciplinary. We live in times that we cannot do research without bridging between different disciplines and bringing expertise from multiple fields. So in this group, we have people who are clinical psychologists, developmental scientists, computer scientists. We have speech and language pathologists. We have social workers. We have, some of us have autism, some of us have relatives with autism. So any work that we do in our group has some relevance to all of us in one way. Some of us are former alumni. Juan was a former postdoc. Right now, she's a member of the Chinese Academy of Sciences, and we continue collaboration. Red Shik, right next to him, and right next to her is a former graduate student and an assistant professor at the Child Study Center, and right now associate professor in Seattle Children's. The most wonderful thing is that we also have a large group of people who are postdoc fellows, people who finish undergraduate studies, come spend with us a couple of years, and they go to grad school. It's a wonderful opportunity to mentor for us the next generation of people who will be leading the field in the future. I'm going to start actually from an unusual angle, because instead of talking about social deficits in autism, I'm going to talk about affective development, and then we're going to talk about what we know, what we've learned about development of social attention. I'm going to cancel that, right? Oh, I'm sorry. I'm seeing something on the screen. It's asking me for a certificate. Yep. Okay, good. And then we're going to talk a little bit more about our most recent pursuit, which is a search for markers of autism in very early developmental stages, going actually back to the last trimester of pregnancy. For those who are less familiar with autism, autism is a neurodevelopmental disorder, which means it's a brain disorder, and it changes depending on the child's age and depending on the child's cognitive level. The core deficits of autism involve social difficulties communicating with others, interacting with others, forming social bonds. And the second domain that's quite characteristic of autism, but not specific to autism, present of unusual motor movements, motor mannerisms, restricted repetitive behaviors, and so forth. Despite tremendous effort over the past 70 years, we still don't have a biological marker for autism. We cannot test, we cannot scan the brain and tell whether someone has or doesn't have it. We cannot run a genetic test or metabolic test, say whether someone has autism or not. So for that reason, in order to diagnose someone with autism, we still rely on analysis of their behavioral confirmatory. What's striking about autism is the fact that it's tremendously variable. Expression of the social vulnerability in autism depends very heavily on a number of factors. Children with autism differ in the type of social difficulties they have. Some could be tremendously perturbed by proximity of other people, whereas others are actually very interested in interacting, but they have great difficulties learning the fluid rules for carrying on successful social interaction. Some children with autism will never develop speech. Others will be verbose. Some will have profound cognitive difficulties. Others will be brilliant in many, many different ways. So what we are talking about autism and social disability is expressed in this very high-dimensional space in which children vary from one another quite a lot. And what brings them together is the presence of social disability. It's a developmental disorder. It's very important for us to remember, because this means that its expression changes depending on the child's age. Different symptoms or different manifestation of autism might be present at 12 months, 24, at 5, at 6, at 30. And it's not always easy to understand how that progression happens, and what are the specific diagnostic markers. At some point, we were very worried, how do we diagnose 18-month person? Now we know. Now we worry, how do we diagnose 30-year-olds who are never detected? What are the features of 30-year-olds who may have autism? Finally, important for us, it onsets very early. It onsets before the age of 2 or 3, and this is basically the developmental space that I'm spending the most time in infancy and early childhood. I'm going to flag very quickly one specific group that's very at increased risk for developing autism, because I'm going to talk about a lot of studies that depend on that cohort. When we think about prevalence of autism in general population, we know that approximately 1.5 to 2 children out of 100 in general population are affected by autism. But there are certain groups within the general population where the risk for autism is higher. One of them are younger siblings of children with autism. Because autism is strongly genetically dependent disorder, the vulnerability for social disability may run in families. So once there is one child with autism in the family, there's a higher likelihood that the next baby in the family will also have autism. The estimates vary between, I would say, 20% prospective studies. Epidemiologic studies return slightly lower numbers. And these estimates also vary tremendously depending on a number of factors. So if we think about autism as a spectrum, or siblings as across the spectrum, we might have a group of children who have autism, another about 20-30% of children who may have something that we call broader autism phenotype, which means social vulnerability without actually crossing the diagnostic threshold. Then we may have further. I'm flagging it because we'll talk about these kids in a bit. So when does autism begin? When do behavioral manifestations of autism? By running prospective studies on babies, younger siblings, we were expecting at the very beginning that we'll see a lot of changes happening here already in the first year of life. That we'll be able to take a 6-monther, interact with them and say, okay, this child has autism. Not true, not true. There's no strong overt signs. There are no strong overt signs that we can lean on just by interacting with a 6-month-old baby and say, okay, this baby's going to have autism. At 12 months, however, we're beginning to see vulnerabilities emerging in social and communicative development. Gestures, eye contact, social interest, play. They're coming online. They may not be horribly specific yet, but we're beginning to see present. At 18 months, we can reliably diagnose about 40% or 50% of children with autism. And by 24 months, this number goes significantly higher. So a lot of work that I'm going to talk about is going to be focused on these earliest stages, early syndromal stages of autism. This is the earliest time when we can diagnose autism reliably. And then we're going to drop back and see, well, if we take more sensitive measures, can we see any markers of autism during these prodromal stages of the disorder? So let's start counterintuitively by talking about affective development. It is very rare that a child with autism only has autism. Only about 25% of children with autism have autism and no other disorders. 70 to 75% of children with autism have other disorders. And one, the disorders are attention deficit disorder, affective disorders. Long. So as you can imagine, there's a great problem with that, because having autism in and of itself highly debilitating. On top of that, have anxiety. On top of that, you have depression. On top of this, you have learning problems. That's even worse. And in fact, many studies show that morbid disorders in autism affect tremendous social cognitive, define educational placement, increased number of hospitalizations and suicide. Don't quite know. It's interesting. Don't know what is the relationship between factors that drive autism and factors that drive comorbidities. Arising from different reasons? Are they arising from the same pathogenic factors and kind of producing somewhat different? We don't quite know, or is one consequence of the other? I don't have time to get into that. It's probably a little bit of each, depending on what kind of problem we're talking about. But in and of itself, this is a set of really interesting questions which we should start pursuing. Clinically, it's a big problem because sometimes autism overshadows morbid disorders. Do you know what overshadowing is? It's when you have one disorder and everybody says, oh, you know, he's active, but this is autism. Oh, you know, he's shy or anxious, but this is autism. So, which means that the child won't get treated with more. It's kind of subsumed. And we still have a lot to learn about how to screen for autism in very young kids and whether the preventative and early interventions for any of the comorbid problems actually work in autism. Still want something from me. Okay. All right. So, because I'm very interested in early development, early detection, intervening as soon as possible, I want to understand, are there any ways in which we can identify vulnerability toward comorbid disorders in babies at the same time when we diagnose them for autism? Right now, the comorbidities are typically not diagnosed until kids are 5, 6, because that's where ADHD is diagnosed, anxiety, depression, later preschool, early school. But when we see kids in the clinic at 18 months, we want to be able to say, okay, this baby might be at risk for developing X, Y, and Z in addition to autism, so that we can intervene at the time when all these symptoms are beginning to appear. So what is the construct that we can target for our research? One of the constructs is called temperament. Temperament is a biologically based predisposition to respond emotionally to internal and external events. It's relatively built in. You know, we can measure temperament quite reliably already in babies. It's relatively stable over time. It can be affected by external factors like trauma, child-rearing practices, and so forth, and other experiences. But in general, it's thought to be a pretty influential factor that can, when taken to an extreme, can predict later on. Temperament is typically characterized along 3 axes. One has to do with positive joy, felt, experience in response to them, word seeking and high level. Negative affectivity, including fearfulness, frustration, anger, distress, response to and control of these emotions. Important because if a baby has a very low capacity for joy, for positive affectivity, research in the general population found that these babies are actually at risk for lower social competence. If it's too much exuberance going on, then these kids are more at risk for development of behavior or externalizing problems. Negative affectivity gives rise, in some cases, to anxiety, depression, and problems with controlling these powerful emotions may lead to externalizing problems, aggression, and so forth. That seems to be a pretty easy and straightforward construct to consider when we want to predict whether a child is at risk for social disability. So this is what we do, taking advantage of a very large component of developmental also probably maybe, I don't think it's a lot of kids, 180 kids with autism, toddlers with autism. Nice controlled group, and 80% of the sample was seen the second time before. So you could look at the projection. And what we found was, when we compared, so this is based on a parent report. We asked parents a questionnaire, and we asked them to work on it. What we found was something very interesting, that already at this very early age, this is the time of the first diagnosis, kids with autism have lower capacity to regulate their emotions, right, than both developmental delayed and typical. They have higher negative affectivity compared to typical kids, but not developmental delayed, and lower capacity for joy. Right? So there are already sort of some kind of a potential risk markers beginning to emerge from the study. What we found was pretty interesting is that the temperamental vulnerabilities were not associated with severity of autism symptoms. It suggests that it's possible that these temperamental problems and social problems are not related, and they might be shaping together the complex phenotypes that we see, but they are not necessarily linked. When we looked at the kids at 4, we saw very actually impressive intra-individual stability over time. And the kind of problems that kids had at 2 contributed to severity of symptoms, not at 2, but at 4, which sort of speaks to the idea of shaping. But we know that using parent report only tells us half of the story. Right? The parent report is great, but it's also colored by what parents see and how they construe the child's development and what their expectations are and so forth.
Very quick question. Was this Perry Rothbard's temperament measure, or?
This is TBAC, yes. This was the early TBAC, which is the precursor of the ECB. Okay. Yes, good.
Is the, given what the measure, which I don't know, is it possible that the lack of correlation at age 2 and then at age 4 has to do with the degree of the measurement at age 2, that there's not
variability?
Yeah.
In the so this would be a question whether there's not enough variability in the autism severity scale, right? Because we have variability in the nothing that, I mean, they are pretty distributed. The range of severities are pretty wide. It's a good question, but I don't think there's a difference in at the beginning. The beauty of it, getting the kids when the symptoms emerge, we don't have any pre-selection. It's a good question. I'll keep it in mind. So, so we decided to do, and we're pursuing this question now. What does it all mean? With 2 R1s, and one of them involves, both of them involves actually measuring emotional reactivity on a very different level, using actual behavior. So using actual behavioral challenges and measuring children's reactivity in the real world. Asking parents, how does your child respond when a stranger walks into the room, or when a new toy appears? We have to do that, expose the kids to strange things, and we measure intensity of emotions as they go on. So I'm going to show you 3 probes. One probes for frustration, one for fear, and one for joy. As we are exposing kids to these probes, we are also measuring their electrodermal activity using little sensors that are actually placed in their ankles. This gives us a sense of what's happening under the hood. What's the physiological arousal that accompanies the vocal and facial expressions which you're going to see. We can hear and we can see what they do with their faces, but we don't know what they're doing inside. What's the autonomic nervous system doing with this information? But we can get that information in the arousal. This is a frustration task.
Looks like fun.
We debrief the babies afterwards. I get to play with a spider. So, what I found was something very interesting. So, what do you think kids with autism compared to typical?
Frustrated?
Frustrated, okay. How about joy? Are they happier or less happy than typical? Fear? More fearful? Okay. More frustrated, more fearful, less happy. Okay. I didn't tell you one thing about this task. So, typically these tasks are kind of mixed social and non-social probes. So a person might, walk into the room and scare the child, or might engage the child face to face. I know it sounds bad. It's not that. It's that. So the problem with the files that you see on the market these days is that they're ambiguous in terms of this social content. So what we did before this study, we stripped this task of social content because we don't want to study autism. We want to study emotion. And so all the tasks that we presented to the kids took very low social content. We just wanted to see what's happening with the emotional system, not with the social system. So the results you see are in response to non-social probes. So what do we see? Said more aggression, more frustration. So kids with autism have a little bit elevated frustration or anger, strain, especially compared to typically developing kids, developmental like not as much with TB kids. So there is an effect, or there is a trend, but not horrible. Joy in response to bubbles, and fear condition is exactly the opposite. They're actually less frightened. Remember, they're responding to non-social triggers. So perhaps what we're seeing is only the manifestation of they cannot display how they feel. Maybe that's what it is. Their faces and voices are not conveying what's happening. That's why we looked at the physiological reactivity. And we see here, the data was available in the SAT sample here. We see that the reactivity was slightly higher than arousal for joy. We start to see some declines as if they're kind of calming. And for fear, we saw the same. So whatever we see on the surface is actually happening inside their low bodies. There's a consistency or congruency between physiological reactivity and behavioral response, with magnitude of the effect of about 3.38 or something like that when you think about correlation between these two. All right, so what was interesting is that there were also no association intensity of any of these negative emotions, just like what we saw in parent report, suggesting that negative reactivity dimensions might contribute separately to the different types. Accentuated anger response might be something that forecasts what is very prevalent and very perturbing later on, which is proneness to irritability and aggression in older children with autism. We don't know that yet because our kids are not old enough. That's something that we're examining. Attenuated fear response is very surprising. We expect this response to be different, and yet in response to objects, they don't seem to understand that novel and maybe striking objects should be feared. We don't know exactly what it is. One hypothesis is that they understand what they're seeing. Again, it might be forecast, something that we see so often in toddlers. And safety issues, knowing what's safe, what's not. And so it also marks tracks with some of the research on adults and so it was lovely. It was lovely to see that kids are responding to positive emotions. It might suggest some kind of source of strength. Because if we can engage kids positively, we can also manipulate their motivation, engage with people, learn from people. And that's a very cool thing. That's a very, very powerful thing.
I just wanted to ask about the fear response. And when we think about the development of fear in toddlers, it is very social in many regards. You learn to be scared of things and social influences on fear. And that was not linked to symptom severity of autism.
Your response was not. But I like what you're thinking because we learn, there's very few things that we're innately afraid of, and that's the question. We learn what to fear by monitoring parental expressions in response to novel objects. This process is called social referencing. So what we might be seeing here is that reflection of lack of social cognitive skills to learn about the world, what's important, what's not, what's scary, what's not. And this ability to, lack of ability to appraise what's scary, what's not, might be mediated by the social. I'm not too worried about these correlations because correlations are tricky, but it's something to explore, examine actually more directly because we have measures of social reference. And it's just someone's got to do it.
Is there what their response is in social situations?
Yes. So we got a grant to run this study, 5-year grant. We cut the data about halfway through, look at these results, and we thought, damn it, we should have done social as a separate condition. We added. Analyzing it. It's different. It's so cool. Very different. It's what you would predict. That when you take individual variability under consideration, you see that there's an accentuated activity. Social triggers. But the beauty of it is that we had the capacity to cut the data in the middle and say, damn it, we really need something more to that, and we're able to do that. So that's this is all credit to my colleague Susan Mackay. It happened. All right, closing up. So tons of questions. So how do babies respond to socially laden triggers? What does it really mean? Really care? Are these really markers? Should we really use them for anything? Do they predict any facets of later psychiatric development? That's what we are working on. Because now we're seeing the cohort that we see at 2 and 3. Now we're seeing it at 5, where we can actually diagnose all the morbidity. Next question is actually, can we drop even younger? Can we actually go to the prodromal stage of development? Predictors of typical emotional level. Finally, what is the actual relationship between typical emotional development along positive and negative affectivity and symptoms of autism? This is a $1 million question. Answer. So before I switch gears, any questions, comments?
We have younger data from these kids. We have like 12-month-old data.
Not from the same sample. Not from the same sample. We are collecting right now. We have data from 4. 8 and 12. Highly data. So the good news is we are able to do that. The bad news is we don't have, it takes a lot of time to grow a baby. So if anybody has a great source of babies, friends, family, anybody wanting to get pregnant, talk to us. Talk to us because we want every baby that's sort of walking around. All right, so are we ready to shift gears? Or all right, so this was I love work on emotions because this is something really new that we are doing. But I love also working on attention because I think we're getting to the point that we might be better understanding of what is happening. So if you've never met Beede, this gentleman is he was a psychiatrist who was the first person to describe the syndrome that he called autism disorder in 1943, and he what he did was he published a paper with 11 cases of autism, first cases of autism. So this is like a Bible in our field. And very keenly, he described the phenotypes of kids with autism. And one of his observations struck a tone with me because he said that what's characteristic of these kids is comings and goings, even if the mother did not seem to register. Conversations going on in their room elicited no interest. What I interpreted is the kids did not orient or didn't sustain attention on things that are superbly important for babies to survive in a real world. If you've never seen what it looks like in reality, this is an example of an 18-month-old child who has autism, otherwise is quite intact in terms of cognition and other skills. And that lack of social orientation to speech and faces is quite
Is there
prominent.
something you can do to make them smile without touching them?
Chase them around.
Give them around?
I'll get you. Helen.
Hey.
I'm gonna get you.
Ooh.
Get you. Why in my chair?
You kidding me? You like the chair now?
What? No, that is good.
So this is probably, for everybody who worked with young kids with autism, this is probably the signature autism at this age. That the most loving and warm and charming dad cannot get a glimpse out of this little child. As if without of social facial expression and smiling, the warmth in his voice made no difference. The moment we understand why this is it, this is the moment we might be able to actually intervene in autism on more mechanistic level than symptom level that we're doing right now. So this was recorded many years ago. This was when we were beginning to work on kids with autism. And one thing that I wanted to do in my lab is to actually understand this phenomenon a little better. The way we can do it experimentally, you can take something you observe in the real world, and you can try to replicate it under control conditions in the laboratory. And then you can vary different elements or features of that phenomenon. Begin to understand what is this really about. Because what we are seeing in this video is obvious to us, right? Everybody responds with a very visceral response. We know this is not right. But what's not right? Why is it happening? What's the story behind that? So what we did, we designed a task, which is an eye tracking task, in which we, instead of having a child interact, we show them a person who tried to interact with them from the screen. The same, turns out to be. And this person was talking to the camera as if trying to engage the viewer. Sometimes she, I'll show you the video in a second, made a sandwich. Sometimes these toys would be also. And as the children were looking at the screen, we recorded their gaze, point of regard, using an eye tracking system, which allows us to map where they look at any given point within a visual scene. And then we can calculate how much time they spend looking here, define regions of interest, and we can also cut this video for different epochs. For instance, when the person is talking, when the person is making sandwich, when the toys are acting as distractors, and so forth. So it gives us a very good sense of how the free viewing attention or selective attention works in kids with autism. When we show this task to typically developing kids, there's a huge cohesion with regard to.
Hi again, sweetie. How are you doing? Are you having fun? You look so cute today.
So stimuli like that produce a lot of cohesion. And so what we did in this first study, we call this task selective social attention task 1.0. Now we're at 4.0. We showed this task to toddlers with autism, developmental delay. I'm showing the abbreviated results, but there were several conditions. One of them involved a situation when she looked at the camera and spoke and called that a kid. Another when she was looking down, sandwich, and then toys were around, the moving toys or distractors. You can see under certain conditions, there's no difference between the groups. So kids with autism don't have any issue with face per se. But when she's talking and trying to engage someone, they increase attention to the face, but not as much as everybody else. What we learned from that study that there's a context specificity to attention, a lot of attention to faces. The study with a study which I actually absolutely love, which is a horrible thing to say, and it's your own study, but it was actually a pretty cool study. It looked horrible if you watch the video. I'm not showing the video because it's so controlled that it sort of loses some of its naturality. But still worked very nicely when he actually wanted to answer the question, okay, so she's looking, she's talking, they're not looking as much. What's causing this effect? Is it the looking? Is it the talking? Is it the face in general? Because she's orienting her face up. What's the story behind that? So we took it apart by showing a video in which there were very specific epochs where the person was looking down and not speaking. So no direct gaze, no speech. Direct gaze, but no speech. Right? We can isolate the effect of the gaze. No gaze, but speaking and talking. Right? 2 by 2. Passive 2 by 2. So it's really cool. Consistent with some of the work here, we see that just looking at the face itself didn't separate the groups at all. These are typical kids. Right? These density plots are sitting on top of it. When she's looking, no difference at all. So it's not about eyes. There's nothing about eyes that makes them sort of not as much. When she spoke, however, you see the density plots that diverge and different sizes are pretty large. When she uses both, additive effect is really, really stunning. So, so this is a nice study which shows, first of all, replicated this on a completely different sample, different show that there's certain conditions which produce this differentiation between the groups. And that condition or dimension that really matters here is speech. Eyes matter. They are not making your brain. Speech is important. So the next question we want to ask is, since then, the study has been replicated in our ABCCT trial in school children. We showed the high inter-individual variability, ability, my work as a variable stratification biomarker, and it's also convergent validity and reported social difficulty. So it's a nice task because it actually works in other labs and also seems to be.
Quick question about the data there. So you have percentage. Is it percentage of time steps, or is it counting fixations?
This is dwell time. So we're not counting fixation. We are measuring time they spend within the ROI. So within the ROI, they might be doing saccading, but they're staying within the ROI. It's standardized by the total amount of time they spend in the scene.
And are there group differences in that baseline? Okay.
Yes, yes. Very important group differences, which we found across all the studies. Kids with autism have a less capacity to sustain attention on visual scenes. And we actually did a very interesting study analyzing similar data from one of the studies using joint and individual variance approach, which is kind of a new PCA, kind of allows you to look at if you have 4 conditions. If you apply PCA, you can do PCA on each of them separately. But Jive allows us to look at the variance shared between the conditions. And one of the factors which accounted for 30% of the variance was the factor of overall attention. So that's, and then there were individual factors which accounted for 30% of the scene. So there's a lot of information in that lack of information or lack of looking.
You must have to be careful to make sure that the frames where you have direct gaze and speech are equally distributed over the period, so that they're not fixing.
Absolutely, absolutely. So we have multiple samplings and we evaluate the time effect and health effect, counterbalance the whole 9 yards and all that. So, but this was a very important question, and we agonized over that.
I don't want to go too far into the weeds, but can I ask you about another aspect of this task that you didn't describe, but I'm guessing is built in, the joint attention?
Yes. No, so built into this task was joint attention to violation of expectation. Sometimes she looks and the toy moves, and sometimes the toy moves and she looks in the opposite location. You notice some kids are surprised. I'm ashamed to say, I'm a narcissist. Need more postdocs. Need more postdocs.
I'm just curious about such a cool. And, what do you think about if you're not playing speech, the person is non-speech sound? Do you think that case?
So you are thinking, okay, if we show them a video of a person just there, and then in the background we play music, or going boing, 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 where would they look?
Well, I feel like I have that because it's what if you have that monkey speaking something? So it's kind of like, similar condition that
So you introduce speech, but it's not coming from the person or something.
Right.
I think these are great questions. We haven't moved there. I'm working with one of my colleagues at Haskins now to try to parse this phenomenon further. It's like every time you make a corner, you find something. It's like, oh, this is cool, and then it's like, what does it mean? So we are working on unpacking. What is about speech and along some of the lines. Stay tuned. If we ever get to it. Again, we need more postdocs. All right, so naturally question. So we see these things in the now the question is, see these things in prodromal stages. Remember I showed this picture, the symptoms that flat early and then go up as well. First year of life. Can you see any of the attentional phenomena that we see in newly diagnosed toddlers? So what we did, we showed them the same kind of video. It was 6 months old. And remember when I told you about this group? This is the brother phenotypes with high-risk children who share some properties with autism, but they don't have autism. High-risk developing and low-risk developing. And what we found was this across all the conditions. Kids who later were diagnosed with autism spent less time looking at it. So interesting because it's a similar, it's not identical pattern, but a similar pattern way before symptoms of autism. And we replicated the study later with very different kinds of stimuli, with static images, person just sitting and smiling, and a person reciting nursery rhyme. We found that only in this condition we saw significant differences between the babies who were later diagnosed with autism, also at 6 months. So there was an interesting convergence showing that even before symptoms come online, this attentional marker might be already present there. Whatever it's generating a typical selective attention in autism might be already operating 6 months. What we did recently, and I'm really pleased about that, this is a paper that's just about to come out, it's been accepted, is we actually showed that same phenomenon in real world, which is an advance over our studies, because we actually created a completely new task in which a person interacts with a child, and it's an examiner, highly trained, so it's a standardized set of probes, which are graduated. So it's 5-minute task. 1 minute is they talk to the baby using motherese, right? Just like the actresses in the video. Another minute they sing. Another minute they play peekaboo. Another minute they tickle the child, and then put them a toy. So very, very structured and very controlled task. And we were wondering if in any of these conditions, babies who later develop autism will show lesser attention to the face of the examiner. It was a painstaking project because we needed to code looking at the face of the examiner using looking at the face. This is how what the task looked like. It's a little snippet.
You're such a pretty girl. You grow so much bigger since the last time I saw you. Yeah, you're getting so big. So star. How I wonder what you are. Baby. Peekaboo. Hi. Where's Gracie? Gracie, where are you? Girl. Here we go. Tickle, tickle, tickle. Tickle.
So 5 different conditions, and here's what we found. Common differences that we saw as 2 conditions which involve speech. It's crazy. I mean, it's really crazy. This is when she talks to the baby. What's the baby? People. We come back to the same theme of context specificity of the social deficits we see in autism, and we keep coming back to the speech as being one of the factors that sort of amplifies the effects or differences between kids who are later diagnosed with it.
Surprised because it seems like peekaboo definitely involves speech. And the song, the melody, but it's also speech.
Right. So
Yeah.
peekaboo also involves heavy-duty perceptual component and also predictability. And so something that's probably well practiced by them, if not, so kids with autism do very well with practice. And they can make predictions based on And also there's a heavy component where you draw attention to the face. That might be, in a lot of studies before which return negative results, we're using people as one of them. So we're consistent with this way. Music, I really want you guys to know. My sense is there's very few studies in autism on music. They appear to have typical reactivity in terms of brain responses. Music. Talked about it during lunch with one of the students about how, at what level that differentiation may happen, because at the beginning the sound is the sound, right? I don't know. You tell me. We are working on it. We are trying to sort of take it apart, but it's interesting, and I explain why there's consistency in the field. That some studies that use a lot of gestural supports in interactions, singing and nursery rhymes, return negative results. So anyway, so why? Yeah.
This really like kind of that children with autism also have problems, but then at the same time they're choosing to do order. So would you be able to kind of help me to understand like relationship in terms of these difficulties, is the cause of things? How do you think about what exactly the language element, autism, is different from like language disorder?
The answer to this question.
Well, I mean, one salient difference in the kids who have developmental language concerns is they often are using compensatory their behaviors, a lot more gesturing, lots of speech. So even though there's less talking, verbalization, there's other channels and not.
The differentiation between these two groups is based on the presence of drive to communicate, right? Frequency of communication and use of nonverbal means for communication, apart from language. How these, if we took children with specific language disorder or a risk of specific language disorder and put to this task, I would be super curious to know what they look like, because that would be actually the answer to the question. Access to this cohort, please let me know. I think the purpose of this talk is just to generate more questions so that we can take them home and do something with them. So all right, so why is this happening? Right, we know that they have problems with selective attention, two faces, dynamic speaking. The more cues, the bigger the difference. See differences in babies, presymptomatic babies. So this is all cool, very exciting, let's celebrate. But really the question is, why is this happening? Because now we are still at the descriptive level. Now we are just beginning to understand better. It's not just about faces, that they don't want to look at faces. It's something more. There are neurocognitive processes that are preventing them from engaging with faces under certain conditions. Why? One of the hypotheses in the field was quite prominent in the early aughts. And I remember I published a paper in 2003 which kind of dismissed that hypothesis. So my paper was dismissed because the other hypothesis sounded attractive, until it turned out that I was probably right from the beginning. So one of the hypotheses was that kids with autism lack the capacity in the perceptual system to detect face-like patterns. Face-like patterns have privileged status in our attention. So even babies orient more towards something that has this classic combination of features. And the idea was that perhaps kids with autism are born without that pre-existing perceptual bias, and once they don't orient to faces early on, miss out on a lot of information. Once they miss out on information early on, they miss more information and cascading effect. there was a very, very attractive hypothesis. It only didn't work because a number of studies show that, for instance, if you show a baby something like that, this is a classic pop-out test or visual search test. They identify faces as rapidly as typically developed already in the very early. We did a study which was a little bit more contextualized and more, we couldn't see a single difference between kids with autism and those with autism. So that was not working. But in the real world, so we know that they orient to the faces fine, right? But in real world, the question of what to do with attention, there are no vegetarians here, are they? Sorry about that. The real question is not to always look at faces, right? It makes no sense to always select faces. Sometimes you need to look at hands and the tools that are being handled. Sometimes you need to look at the object of action. Sometimes you need to look at the background to really understand what's going on. So faces are not, we are prepared to process them. If we look at them all the time, we are going to miss a lot of information. So in real world, we actually need to look at the scene and pick whatever is important, and whatever is important depends on the situation. And sometimes it's not one face. Most of the time, it's not one face. It's a lot of faces. Right? And we need to be able to look at them and see which one is the most important. Which one carries the most information? Which one's going to tell me what's going to happen next? And that's a very important social cognitive task. That it's not given. We don't know a priori. We need to learn every time we make a decision. An implicit decision. We make a decision where to move our eyes or delegate our cognitive resources at a given point. And that process is actually driven by what we call value learning. Right? Our eyes constantly forage for information, just like squirrels forage for milk. And multiple studies in primates, beautifully modeled work in primates, suggest that selective attention is driven by appraisal of the informational value of the stimuli, faces, hands, tools, whatever. And few values are given. Most of the time, we have to learn them. Sometimes we have to learn them very rapidly. Sometimes we learn them, store them in long-term memory. They're learned. This is a learning process. It's mediated by one of the subsystems of the reward system in the brain. There are multiple studies that show that attention to high-value objects is enhanced in humans. We detect them faster, we look at them longer, whereas attention to low-value objects is actually... Okay, with me? So when we think about autism, we know that this is okay, right? Reflexive orienting appears to be okay. We will selective problem. So we hypothesize that value learning might be an issue. And value learning hasn't been really studied in autism. There are very few studies which tap into the question of value learning in adults using probabilistic learning tests, which meant to evaluate whether learning of value of objects depends on the type of reward. Social reward, you get a smile or good job praise, or non-social reward, I don't know, you did something, I don't remember what it was. And value of learning in adults appears to be affected by rewards or so. How do things, social things, acquire value? Right? How do we know that something social stimulus is value? How do we learn that the smile is a good thing? How do we know that a nod is a good thing in culture? How do we know that this is not a good thing? Right? We learn, right? So I was very interested in how do we learn value of social objects? How do social objects become rewarding? What we decided to do is to study how value learning affects selective attention? That question is never been asked. And partly because we don't have very good methods to study this phenomenon in young and nonverbal kids. So what we did, I actually looked very closely on how primates in the past, based on primate work that we employed in babies. The tasks were very simple, but the codec is not available, so I'm not sure. Anyway, so we showed sitting in front of the screen. One face pops on the screen, the child looks at it, nothing happens, goes away. Another pops on the screen, child's look at the face smiles. Away. So we have face A, face B, low value, high value. Anytime child looks at a high value face, the face smiles, low value smiles, never does anything. And you show them two at the same time. Which one do they pick? Do they pick high value face or low value face? Simple task. Do the same thing with fractals. You look at one fractal, nothing happens. You look at another fractal. The fractal starts doing the cool stuff, which keeps you looking at your screensaver for hours. Very attractive. And again, you show them two fractals at the end, the same fractals, which one do they pick? High value or low value? Simple. The task was a little more complicated, but it doesn't matter. So you can probably read about this. So what we found was we actually did two studies. And let me tell you about this study because this one is established. So what we found was something very interesting. That kids with autism showed baselines. At baseline, we showed them two pairs of faces or fractals before learning. After learning, is that kids with autism have difficulty learning value of faces compared to kids with developmental delay. They were superbly at learning factors. That's kind of interesting. Imagine that you have a natural propensity in your value learning system to learn value of non-social objects like factors, and lesser capacity to learn about the importance of faces, which faces important. It's going to kind of skew your attentional selection very early. And so we are very excited about this line of work. We're still developing these techniques, but I would put a lot of money on value learning as one of the aspects.
I assume you did some work to establish that, curious how one might do this, that the degree of difference between the high value and low value faces versus similar color, and
we did a lot of matching within category. Yes, we did a lot of Qualtrics ratings, matching them on intensity, on color, on enjoyable aspects, and all that. So yeah, quite a bit. But these are very important questions. All right, so moving on. So going back to the question of why do kids with autism have poor attention to faces under certain conditions? We talked about one thing, the question of maybe they don't recognize that faces or specific faces have value or they're important, have salience. If so, then we would expect that the salience network that involves the reward system might be affected in autism. Right? Another reason, which is these are not necessarily mutually exclusive reasons. Another reason might be that perhaps some children with autism spend less time attending to people's faces, especially when they are demanding, in essence, of speaking or is because they're somehow perturbed by amount of information or type of information. In which case, it will be reflected in their arousal level, and that would be associated with the activity of the amygdala system, associated structure that involves processing the emotional side of it. I know the third hypothesis, which again is not mutually exclusive or present in some children with autism, is that they know faces are important. they're not perturbed by them. They just cannot regulate their attention. Everything is important. They look at everything, and they cannot focus on one thing because they are highly distractible. They cannot inhibit attention to other relevant areas. In which case, we would talk about some disruption in the executive. So what's very interesting about these networks that I'm talking about is, remember, we at 6 months we see these emergent difficulties in social care. Right? Interestingly, these networks that I just mentioned are beginning to emerge in babies much earlier, way before 6 months, in newborns as well as pregnancy. Here, for instance, is sort of a shows development of the amygdala region, amygdala network, starting at 30 weeks of our colleagues at 30 weeks of gestation. What we're seeing here is the touch of activity on one side, not much proliferation in 4 weeks. The activation sort of spreads a little bit further on the same side, but still on the observer side. And then by the birth, the activation spreads between sort of activation on the sides of the brain, which sort of marks development of the regular emergent networks involved in salience, also been reported in newborns. So what we are doing right now, and this is the work that Nika mentioned at the beginning, what we are doing right now is we have some signals here at 6 months. We are right now trying to identify properties of the emergent networks prenatal and neonatal, and link them with the emergent difficulties in attention, starting at 4 months and extending until the age of 2. We are doing it by imaging moms, pregnant moms, in the last trimester, which is an interesting idea if you want to study development. And we also study we are using imaging, and we are extracting patterns of resting state functional connectivity. These patterns are very interesting because they arise spontaneously. You don't have to have a task to activate these networks. These networks are active in the background, constantly churning and prepared to receive upcoming. And this network seem to fire together, networks seem to fire together, or areas seem to fire together where they are sort of tuned to process specific types of information, visual and detection. So, what's interesting also that the topology, haptotopology very early on, and strength of connectivity within networks and between them has been linked with later of development of developmental anxiety. Also, what's great about this method is that it's a safe and non-invasive approach that uses after relatively recently, we didn't have a really good sense of what's happening in development. The idea was that during fetal development, last trimester, what we see most often is developing sensory and motor networks. But since then, there have been multiple reports about the cortical and limbic areas, cerebellum, and regions which are involved in language, including Wernicke area, and physical gyrus involved in sort of social information. Also emergent during neonatal period, we already see precursors of the network. networks that are important for having implicated in autism, including mode series systems. And we know that even in neonates and also in fetuses, properties of these networks are linked to later outcomes. So for that reason, we are bringing babies to our lab and are now recruiting them when they are months are 30 weeks pregnant. Again, if you can get pregnant, you know Is that? So, and following them until it's a wonderful study. It's difficult to find high-risk families, but once the families commit, our retention rate is through the roof, even though we see them very, very frequently history of life. So, and we make them feel like royalty. So, which is important because the families are giving us so much that we want to be able to give back. And as you imagine, you know, many families who come to us, they come with the question of, will my child develop autism? Will my younger child develop autism as well? So what we provide, we monitor the child's development as they come and address any concerns they may have or concerns that we may have. So we provide monitoring. Now, since you've been so patient with me, I'm going to show you the bonus video. And the bonus video is actually something pretty amazing. This is something that Dustin Scheinhaus at department, one of our collaborators at the Department of Radiology put together, which is a video that shows how can we stabilize an image of a fetus within mom's abdomen at, I don't know, just I think 34 weeks or so. So you can imagine, you know, we can scan newborns when they're asleep, right, and limit their movement. Right? We would never give them anything for them to sleep. This is natural sleep. In terms of fetuses, it's really hard to know when they are ready to sleep and when they are ready to play. So we are really at mercy of what we do. So the only thing we ask moms is please don't have any energy bars right before you come to daddy. God forbid moms have sugar before they come or caffeine. Ooh, then the fetuses are sort of jumping around. So we try to get moms at the time when they're, you know, calm and quiet. But still, a lot of work needs to go to processing this data because we need to align the data. You know, you never know in which position the data is going to be, right? It's not like we can put the head in a coil. They will be in any position, in any place in the scanner, wherever they feel like it. So there's a lot of work goes into actually abstracting these images. So this is a video that Dustin put together. This is mom's abdomen. See the baby's head. The resolution is not good on the screen. The cool thing about that is that you'll see everything moving in mom's abdomen. Everything's going to move except for the baby because the baby's been stabilized. The image of the baby has been stabilized. The baby has not been stabilized. All right. You need to see like it goes slice by slice. You need to see the skull right there. The eyes. The little brain there. Frontal, back. Okay. So we are very excited about this study. Now we have a number of fetuses and then newborns who completed 3 time points and this data. Point. It takes a village to do a study like that. We have our ACE project, Todd Constable, myself, Laura, and Laura and Katarzyna studies. It's a whole different story. This is a really cool study. We use pluripotent stem cells for remodel brain development using skin cells. Joe Chang from the Department of China, our crew, directors about Susan Macari, I mentioned before, Jamie Merck-Parkland. And as always, I'd love to thank our families and funding agencies. And this is our current, well, it's always changing. Pretty much up to date. I wanted to thank you so much for your attention. And keep in mind, pregnant moms, send them to us. Thank you so much. Thank you.